In this lesson, we're going to examine how we can solve a system of equations using some algebraic methods. To get there, though, we need to talk about the graphical method first. So they'll review for us here. We want to find the solution to this system of equations. So we're going to graph this. There's my y-intercept, positive 1. My slope is up 1, right 1. So I can make a bunch of dots. Draw it straight. And do the same thing for the next one. This y-intercept is negative 2. The slope this time is down 2. It's a negative. And right 1. So down 2, right 1. It goes off the graph. So I can reverse it and go up 2 and back 1. Kind of handy because I can see the point of intersection right there. And there's that line. And our POI, that's our solution, is negative 1 and 0. Now let's talk about that point of intersection. That point of intersection is the one point that has the exact same coordinates on both lines. They both have a point of negative 1 and 0. In other words, they're equal at that point. If we can take that idea and think about it in terms of an algebraic expression, that means that those two equations are equal to each other at a single point if they cross. They have to be equal. So what does that mean? Well, that means we can solve these things by making the two equations equal to each other. You can either make x equal x or y equals y, depending on the situation. So let's look at this first example. I have a system. I know they're going to meet because our slopes are different. That's why we talked about finding those slopes and types of solutions before we did this. If they meet, then at some point the y has to equal the y. These two things must be equal to each other. And if those two things are equal to each other, then 3x minus 4 has to equal 2x plus 1. This must equal this at some point. And if you just stop before you solve this, I hope you recognize that this is equation number 1, and this is equation number 2, and we're comparing them to each other, putting a mirror down the middle, if you will. Where they're equal is where they are the same. So let's solve that. How do we solve these things? Well, we put numbers on one side and letters on the other. So I can bring the 2x over here, it becomes a minus 2x. I can bring the 4 over here, it becomes a plus 4. And I've just figured that x is 5. And once I know x, I can go back and find y. And I can do that because I have two different equations that can be used to find y. So let's pick one. Let's pick the top one. And if I put x in as 5, which we think it is, I get 15 minus 4, which is 11. And just to check it, let's try the other equation. Y equals 2x plus 1. And again, if I put 5 in there for x, I get 11. So no matter what, when x is 5, y is 11. In other words, our POI is 5, 11. This is your x, this is your y. And now you don't have to check both, you just have to check one. But it's a good idea to think about the other one because you can check your answer that way. Let's try one yourself. So pause the video, see if you can figure out how to do this one yourself. I want to know where these two equations are going to meet. I know they have to meet because they have different numbers as their slope value. Not exactly slope, but same idea. They're going to meet. They have to be equal. If they're equal, their equations have to be the same. Now notice this time we start off with x equals x because that's how this was set up. But the process is the same. 4y minus 2y equals negative 7 minus 5. So bring the 2y that way, the 5 that way. We'll get 2y equals negative 12. And if I divide that out, I get y is negative 6. Once I know what y is, I can go back and get x. I can use either equation. I'm going to pick the top one. 4y plus 5. And I think that y is negative 6. So I'm going to replace it. We're evaluating here. I got negative 24 plus 5, which is negative 19. If I want to check it, I can. I go back up and think about, let's look at the other equation. X is 2y minus 7. This is a check. I'm not resolving, I'm just checking. See if I did my math right. Negative 6 minus 7 is negative 12 minus 7. Hey, that's negative 19. Hey, I got the right answer. my POI is, be careful here, put in the right order, x comes first, negative 19 and negative 6. This is your x and this is your y. And I know it's the right answer because I did my check. I did this check over here. Got the same answer either way. So that's one method of solving these things. We call this method comparison. Okay, thinking about these two things have to be equal. They have to be the same values. There is a second method we can look at. We call this one substitution. In substitution, again, we're finding a single point of intersection, but we're going to find it by substituting one equation into the other. So for example, the first idea here, example A, I know that x is 4. Now technically x is 4 is a vertical line. And I have some other equations, a diagonal line, it's got an x and a y, and they're going to meet somewhere. They have to meet. A diagonal line and a vertical line have to meet somewhere. They're different slopes. I can find the point of intersection by taking x and putting it in for x. Like we just did a second ago when we solved by comparison. Once we knew our first answer, we went back and figured out the second answer. So if I substitute it in and replace x with 4, the rest of the equation is going to stay the same. I'm going to have to get rid of my brackets. I'm going to have to rearrange this so I get numbers on one side and letters on the other. So I'm going to bring the 12 over here. It becomes a minus 12. I get 2y is negative 10, and if I divide that out, I get y is negative 5. So I have found my point of intersection. We already knew that x was 4. That's what it gave us in the question. So my POI is 4 and negative 5. That's substitution, putting one equation into the other. Now what's nice about this is when I substitute that equation, it was just a value. But it doesn't have to be a value. It can be an expression itself. If I look at example 2, or letter B here, again I have x equals, but this time x equals this expression. So I'm going to do the same thing. I'm going to take that expression, I'm going to substitute it in for x. When I sub in, I put it in brackets. Okay, the rest of the equation is going to stay exactly the same. So the plus y, the minus 4, stay plus y minus 4. And then I'm going to follow the same procedure. I'll get rid of my brackets, so I'll distribute. I'm going to rearrange, so I have letters on one side and numbers on the other. So about the 2 over here. I got 3y is negative 6. And I divide it out, and y is negative 2. Once I know what y is, I have to go back and figure out the x. Now the nice news is I have x equals. X is equal to y plus 1. And I know y is negative 2. So I can do negative 2 plus 1, which is negative 1. And now I have my POI. X is negative 1, y is negative 2. Make sure it's in the right order. And I've solved it. And that's substitution, putting one equation into the other. And we've been doing it with values for the last 2 years, like this kind of thing. Now we're just doing it with a equation, like with this kind of thing. But the process stays the same. So, you guys to try one. Okay, so pause the video, see if you can do letter C by yourself. Then we'll talk about D. In C, I know that y is equal to 3x minus 2. So I'm going to put all that in for y. So 2x stays 2x minus, there's a 2 here, so I need a 2 out front. Y is 3x minus 2, and the 8 stayed the same. So all I did was replace the letter y with what y was equal to. Now I'm going to expand. Negative 2 times 3 is negative 6x. Negative 2 times negative 2, and be careful here, it's a positive 4, comes out to 8. I want to put letters on one side, numbers on the other. So I'm going to bring the 4 to this side, subtract it. So I'll get negative 4x is 4. Divide it out, I get x is negative 1. Once I know x, I'm going to go back and get y. Y is equal to 3x minus 2. So we know x. X is negative 1. And if I put that in my calculator, I get negative 5. So my POI is negative 1, negative 5. Okay? Okay, letter C, D. D is different, sort of. In D, if I want to use substitution, I don't have a letter that's by itself. In the first 3 examples, I always had something like y equals or x equals. In this equation, in this system, nothing is by itself. But I think it's pretty easy to get something by itself. For instance, I could rewrite the first equation as x equals 2 plus 3y. And if that's true, then that could go in for x. Now, some people are going to say, well, why didn't you rearrange the second equation? I totally could have done that. I could have got this one to be y equals 3 minus 2x. And we're about this 2x over here, right? That totally would have worked too. And I could sub that equation in for y. That also would have worked. I'm going to do the first one just because I felt like doing the first one. There's nothing wrong with doing the other version. You'll get the exact same answer. Okay, I'm just going to do it this way. So 2 times x. X is this stuff. So in brackets, 2 plus 3y. And then the rest of the equation is the same. So plus y equals 3. Let's distribute. So 4 plus 6y plus y is 3. I got 6y plus y is 3 minus 4. Bring the 4 over. I got 7y is negative 1. Uh-oh. When I divide out this time, I get y is negative 1/7. And this is why our algebraic method is good for us. There's no way I could graph and get an answer of negative 1/7. That would, it's just between nice points. But when I do algebra, I can do fractions. Okay. I need to get the x that goes along with it. So back to the beginning, we know x equals 2 plus 3y. And that's the equation we rearranged. But I know something about y. We said that y is negative 1/7, and I want you to keep it as negative 1/7. Don't turn to a decimal, because that's rounding. That's what the graphing method would be used for. You have to approximate. I want to get the exact answer. So I'm either going to use my fraction button on my calculator, my ABC button, or I'm just going to do some math. When I do fractions, I go straight across when I multiply. So I end up with negative 3/7. When I want to add or subtract fractions, I need common denominators. So I times this by 7, so I times this by 7. And when I subtract them, I get 11/7. So my POI for x was negative 1/7, and y was 11/7. That's kind of why the algebra method is good for us. Yes, it can solve all the easy ones, the nice points, but it can also solve all the messy ones, the fractions, the weird decimals, the big numbers, or the really small numbers. Okay, last thing. Let's look at a word problem. So our objective here is, yes, we're solving things, but we want to be able to apply this. So we got to start practicing those word problems we learned how to set up. So what will a good solution look like? What do we need? Well, the first thing we need is let statements. Okay, so what do we have here? Let's read it. The sum of two numbers is 365. One of the numbers is larger than the other by 37. Determine the numbers. Okay, I don't know what the numbers are. So x equals the first number. And similarly, y could be the second number. So that's step one. Give myself let statements. Step two, what else do I need? I need some equations. What do I know? I know the sum, that means when I add things, it's 365. So x plus y is 365. I also know one of the numbers is larger than the other by 37. So I can say that x is y plus 37. It's 37 more than the previous number. Now, if you had turned this around and said, I don't know, y equals x plus 37, would that work also? Sure it would. Or even if you had said that the difference between the two numbers is 37, that would also work. They're just different versions of this equation. They're all going to get you the same answer, though. Now, this looks to me like a substitution question. So step three, we got to do the math. We got to take this stuff and put it in for this stuff. What's that going to look like? X is y plus 37. So I end up with y plus 37, that's x, plus y equals 365. I can solve this. Y plus y, letters on one side, numbers on the other. I'll get 2 y's. 365 minus 37 is 328. I divide that out and I get 164. Y is 164. Oh, okay. But I need the other number. How do I get x? X, we said, was y plus 37. So what's y? Y is 164. 164 plus 137 is 201. Okay, so I got my numbers, I think. What's the last thing I need? My therefore statement. So part number 4, therefore, the two numbers are 201 and 164. Now, me personally, I would check my answers. How could I check them? Well, the question said the sum of two numbers is 365. So do those two things add up to 365? 201 plus 164, yeah, makes 365. It also says one of the numbers is larger than the other by 37. Is that true also? The difference between 201 and 164 is 37. So those must be the right answers. I know the right answers. I've checked it. And that's the end of this lesson. Okay? Algebraic methods. Our homework today is a handout sheet. So print it off. The answers are at the bottom, so you can check them out to make sure you know what you're doing. If you're stuck with some things, come see me because we're going to keep adding algebra skills to this and more word problems. So we need to sort of stay on top of things.